Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at redox reaction. Before we start, if you are new to MyScience Tutorial, kindly consider subscribing and then pressing that notification button so that you don't miss any of our tutorial videos on biology, chemistry, mathematics, and physics. So let's begin. We want to look at redox reaction in this tutorial, and we want to know what the definition of redox reaction is before we proceed. So a redox reaction is a reaction that proceeds with loss and gain of electrons simultaneously. Or we can also say a redox reaction is a reaction that occurs with change in oxidation number of the relevant species involved. So what redox reaction simply means is this reaction proceeds where some species in the reaction gain and then others lose electrons, or some species in the reaction have their oxidation number increasing and others have their oxidation number decreasing. So when we have these two scenarios occurring at the same time in a reaction, then we consider the reaction to be what? A redox reaction. Now the term redox means reduction and then oxidation reaction. That is where how come they have the two joined together to form redox reaction. Now let's have a look at what oxidation means. So we have three definitions for oxidation, or four. So oxidation is what? The addition of oxygen to an element. So we have over here 4 moles of iron plus 3 moles of oxygen gas, giving us what? 2 moles of iron oxide. Now if you look at this, we can say that oxygen has been added to iron, and then we have this compound that we have over here. So this is a typical example of what? Oxidation. Or oxidation is the loss of electrons by a species. So we can see copper over here at its ground state. It does not have any charge, but then it has lost 2 electrons to form what? Copper 2 plus the electrons just to balance the equation. So we can see that copper over here has lost what? 2 moles of electron. So that can also be considered as what? Oxidation. Now another definition of oxidation is what? The removal of hydrogen from a species. So we can see over here we have the H2S over here losing the hydrogen to chlorine and then now forming S. So we can say what? H2S has been what? Oxidized because it has lost what? Its hydrogen. Now one thing we need to take note of is the fact that oxidation always occurs with what? Increase in oxidation number of the relevant species. So in the case of iron, in the first scenario over here, we can see that iron in the ground state has oxidation number of 0, and then if you calculate the oxidation state of the compound over here, the oxidation state of iron over here is what? +3. So we can see iron has moved from the oxidation state of what? 0 to what? +3, which is what? An increase in oxidation number. So all redox reaction that occurs, oxidation normally occurs with what? Increase in what? The oxidation number of the relevant species. Now let's move on to reduction. Reduction is the removal of oxygen from a species. So we have zinc oxide over here plus carbon, and then the zinc loses its oxygen to carbon. Okay, so because oxygen has been removed from zinc oxide over here, it means what? Zinc oxide has been what? Reduced. Or the addition of hydrogen to a species. So we have, as this example over here, we have hydrogen being added to the chlorine molecule over here to form 2 moles of what? HCl. So it means what? Cl2 has been what? Reduced, whilst H2S has been what? Oxidized. Or the gain of electrons by a species. Okay, so we have chlorine molecule over here gaining 2 electrons to form what? The chloride ion. This is also an example of what? A reduction reaction. So reduction occurs with what? Decrease in oxidation number. So we need to take note of that. So whenever you calculate the oxidation number of a species before and after a reaction, and then you notice that the oxidation number has decreased, probably from +3 to +1. This is what? Reduction has occurred. There has been a decrease in the oxidation state of the species involved. So this is just a brief intro. Now we want to look at something we call reducing agent, or the reductant, and oxidation agent, or the oxidant. Now this should be oxidizing agent. So it's oxidizing agent. So reducing agent or an oxidizing agent. Now, the reducing agent is the species that has undergone oxidation, and the oxidizing agent is the species that has been reduced or has undergone reduction. What do I mean by this? Let's have a look at an example. So we have here copper 2 plus zinc, giving us copper plus what? Zinc 2 plus. Okay, we can see over here that copper has the oxidation state of what? Plus 2, and then zinc in its elemental state has oxidation state of 0. Then copper in its element state or elemental state is 0, and then zinc over here is what? Plus 2. So let's note, we have copper 2 plus moving to what? Copper. So we have what? Plus 2 to 0, which means what? The oxidation number has what? Reduced. So this is what? Reduction. Reduction has occurred over here. Okay, so because reduction has occurred over there, it means what? Copper 2 plus is the what? Oxidizing agent. I repeat, copper 2 plus going to copper. So we have oxidation state of what? Plus 2 to 0. So which means this reaction is what? Reduction. Because this reaction is a reduction, it means the copper 2 plus is what? An oxidizing agent. Okay, now zinc moved from zinc to zinc 2 plus. So we have zinc over here is 0 and then plus 2. So it means this reaction is what? Oxidizing, or oxidation has occurred. Okay, so it means we have an increase in oxidation number, so oxidation has occurred. So it means the zinc over here, let me use another color. It means the zinc over here is what? Is our reductant. It's our reductant or our reducing agent. And then our copper 2 plus over here, because the reaction has undergone the reaction is reduction, this copper 2 is what? Our oxidant or our oxidizing agent. Now this is just example number 1. Let's have a look at another example so that we can understand what we are doing. So example number 2, we have 2 moles of aluminum plus Fe2O3 giving us Al2O3 plus 2 moles of what? Iron. Okay, so if we calculate the oxidation state of aluminum in its elemental state is 0, the oxidation state of iron over here is plus 3, then the oxidation state of aluminum in this compound is plus 3, then the oxidation state of iron over here is 0. So let's see, we have aluminum giving us this, so we have 2 moles of aluminum giving us what? This compound. Okay, so we've moved from the oxidation state of what? 0 to what? Plus 3. So this is what? An increase in oxidation. So this is what? Oxidation has occurred over here. And then we have Fe2O3 giving us 2 moles of what? Iron. So we have this over here is plus 3, and then the iron over here is 0. So we have what? A decrease in what? The oxidation state of iron in this case. So it means this reaction is what? Reduction. All right, now like I said, because this side has undergone, because aluminum over here has undergone oxidation to give us this, it means aluminum over here is our what? Reductant or our reducing agent. Let me use another color for that. All right, it means this is our reducing agent. And then because this iron here has undergone reduction, it means the compound over here is our oxidizing oxidizing agent or oxidant. Okay, so depending on the reaction that occurs, then if reduction occurs, which is what the reduction in or the decrease in oxidation number, then the species involved is what the oxidant. The first species is what the oxidant. If oxidation occur, then the first species is what the reductant or the reducing agent. Now, with this little introduction to oxidation and then reduction reaction, let's go ahead to see how to actually solve a problem on redox reaction. Now we have our first example over here. So we are to balance this reaction over here, and then it is in what? Acidic medium. Acidic medium. Alright, so first of all, when we want to balance a redox reaction, we need to what? Write two equations. So we have what we call one, the oxidation half equation, and then two, we write the reduction half equation. Okay, now we need to know the species that has been oxidized and then the species that has been reduced, so that we balance them separately and then add them at the end of the reaction to get our reduction and then oxidation balanced equation. So let's calculate the oxidation state of what? Nitrogen in this compound. So we have what? HNO3. So HNO3. So this is 1 plus, we don't know nitrogen is X, plus 3 into bracket, oxygen is -2. Then we don't have any charge on the compound, so it's equal to 0. So we have X plus 1 minus 6 is equal to 0. So we have X, this is what? Minus 5 equals 0. So we have S is equal to what? Plus 5. So the oxidation state of nitrogen here is what? Plus 5. Now let's look at NO over here. So we have NO. So we don't know, this is X. Oxygen is what? -2. There's no charge on the compound, so it's equal to 0. So we have X is equal to what? Plus 2. Can you see that the oxidation state has decreased from what? Plus 5 to what? Plus 2. So it means what? This compound and this has undergone what? Reduction. Now automatically, the moment we know those two has undergone reduction, then it means this and this has undergone oxidation. It's just like a true or false statement. So you are either right or wrong. So once we know that this one has undergone reduction, then this one is undergoing what? Oxidation. So we've now identified our reduction half and then our oxidation half. So let's go ahead and finish solving this question. Okay, so let's write down our oxidation half reaction. So our oxidation half, so we said the copper has undergone what? Oxidation. So we have copper 2 over here giving us what? Copper 2 plus. So let's balance this. This is in acidic medium. Okay, so in acidic medium, first of all, we want to balance what? The atoms that are involved. So we have copper here, we have copper here, we have 2. Copper is 2 over here, it is 1 over here, so we bring 2 over here to balance the copper. Now we have oxygen here, we don't have oxygen here, so we need to introduce what? Oxygen into the system. In an acidic medium, we add water to the side deficient of what? Oxygen, and we add what? A proton or H plus to the side deficient of hydrogen. So what do I mean by this? We have 1 mole of oxygen over here, so we add what? Just water to this side. And then now that we've introduced water, we have 2 moles of H over here, so we add what? 2H plus over here to balance the hydrogens. Now that we have this, we can see that the charge over here is what? Plus 2. The charge over here, this time this is what? Plus 4. So we need to balance the charge as well. So balancing the charge, we need to add what? 2 electrons to this side, so that the charge will decrease from what? Plus 4 to plus 2. So we add what? 2 electrons over here. So this now balance our what? Our oxidation half equation. Now let's go to the reduction half. The reduction half equation. Now the reduction is this one. So we have HNO3 giving us what? NO. Now for us to balance this, first of all, we need to take away the proton over here. So it becomes what? NO3 minus, giving us what? NO. Alright. NO. Alright. So because we have this, we have nitrogen here, we have nitrogen here, we have 3 oxygen over here, we have 1 over here. So it means this side is deficient of what? Oxygen. So we add what? Plus 2 moles of water. Now that we've added 2 moles of water, we now introduce hydrogen, which is 4 over here. So we need to balance here also with what? 4H plus. Now we can see that the charge over here, this is 4 times the positive over here is 4. Then there's 1 negative over here. So the charge here is what? Plus 3. And then there's no charge over here. So we add what? 3 electrons to this side to make it neutral as this side over here. So it means this side of the equation is also balanced. But then there is one thing we need to take note is that what? Before we add these two equations to get our overall reaction, we have 2 electrons over here, we have 3 electrons over here, but we need the electrons to cancel out because we don't want any electrons released in the system. So we need to what? Multiply this with a factor so that the electrons over here will be the same, and then we can do what? We can add the 2. So we multiply the oxidation half equation what? By 3, and then we multiply the reduction half by what? 2. So if we do that, we are going to get 3 moles of this plus 6 moles of this, giving us what? 6 moles of copper 2 plus, and what? 3 moles of water plus 6 electrons. Now the bottom one, we are multiplying it by 2, so we have 2NO3 minus plus 2 times 4 is giving us 8H plus 6 electrons, giving us what? 2NO plus what? 4 moles of water. So now that we are having 6 electrons in all, so we write the overall what? Reaction. So the overall reaction, we just add the ones that are in green over here to get our overall reaction. So we write what? 3Cu2O plus 2NO3 minus, then plus, we have 6H plus over here, we have what? 8 over here, so it's giving us a total of what? 14H plus. Then the electrons will cancel out. Okay, so we don't have electrons in the system again, they will cancel out. So we have 6Cu2 plus 2NO, then plus, we have 3 moles of water, 4 moles of water over here, so it is giving us the total of what? 7 moles of water. So this is the overall reaction for this question that we have over here. So if we've grasped the understanding of this, let's look at another reaction in basic medium so that we know how to balance that as well. So we have this to balance, and it is in what? Basic medium. Okay, now in case you are given this question without the medium, notice that we have an OH minus over here. So the OH minus over here is telling us that what? This is in basic medium. Now in the previous one that we did here, we can see that even if you're not given the medium, you can see an acid over here. So this should tell you that what? It is in what? An acidic medium. Alright. So with this, first of all, we need to know what? The species that has been oxidized, and then the species that has been reduced, so that we write our oxidation half and then the reduction half. So let's go ahead. So we have this one over here is what? Plus 3. And then over here, if we calculate the oxidation state of bismuth over here. Let's do that. X plus what? 3 into bracket minus 2. The charge on the compound is what? -1. So we have x minus 6 is equal to what? -1. So s is -1 plus 6. So s is what? Plus 5. So we have what? An increase in oxidation from what? +3 to +5. So it means this compound and this compound are undergoing oxidation. Now the moment we know these two are undergoing oxidation, it means this and this are undergoing reduction. Okay, it's just that simple. Once you find one, the second one is automatically the opposite. So let's go ahead and then solve our problem. So it means our oxidation half for this is what? Bismuth 3 plus, giving us what? BiO3 minus. Alright, so let's balance this. So we have Bi over here, Bi over here. We have what? This is in basic medium. We have oxygen over here. We don't have oxygen over here. So we need to what? Introduce oxygen. Now, in basic medium, when we want to introduce oxygen, we add what? OH minus. Okay, and then because we add OH minus, it means we've introduced hydrogen. So we need to balance hydrogen at the other side. So we add what? Water. Now remember, when we were doing the acidic medium, I added a specific number of what? Water and then H plus to balance. Then basic medium, you need to just add them first, and then before you try to balance them out. Okay, so if you can see over here, the oxygen here is 4. Now if we add 4 over here, for instance, if we add 4 over here, we can see that hydrogen here is 4, but then hydrogen here is 2. If we bring 2 over here, it means what? Oxygen is now 5, and then oxygen is 4 over here. So it means what? We are not balancing this right. So we need to take our time and look at factors that will what? Help us get our answer. Now in this case, if we add what? 6 moles of what? OH minus over here, and then we add 3 moles of water over here, everything will be balanced. So let's go ahead and see. So we have 6 oxygen over here. This is also 6. This is 3. This is 3. Now the hydrogen is also 6 over here. It is 6 over here. So it is what? Fully balanced. Did you notice how we added the OH minus and then the water before we tried to look for factors to balance them? Yes, that is how we go in basic medium. So in basic medium, we take it step by step, not as straight as in acidic medium. Alright, let's proceed. So we have a charge of what? This 6 will multiply the charge. So we have -3 over here, and then over here we have what? -1. So we need to make this side also what? -3 to have over. So we need to add what? 2 moles of what? Electron to this side of the equation. Alright, now that we've balanced the oxidation half of this part of our equation, let's go to the what? The reduction half. So the reduction half, we have our MnO4 minus giving us what? MnO2. So the same way, we have Mn common to both. We have 4 oxygen over here, we have 2 over here. So which means this side is deficient of part oxygen. So we add what? OH minus over here, then we add water over here. Now for the second example, if we add 2 moles of water and then 4 moles of OH, this equation will be balanced. So that is what we've done over here. Now if we look at this, we have what? Yes, a charge over here, and then we have 4 over here. So it means we need to add what? 3 moles of electrons to this side to make it what? 4 4. So let me rewrite this over here beautifully. So we have this plus 2 moles of water plus 3 moles of what? Electrons to balance the charge. Then we have MnO2 plus what? 4 moles of what? OH. Now remember, we have 3 moles of electron, 2 moles of electrons over here. So it means we need to get electrons to be what? In a common factor, so that we can be able to what? Cancel them out in the overall reaction. So it means we multiply the reduction half by what? 2 to get this to be 6. and then we multiply this side by what, 3, to also get this to be 6. So let's do that. So we have 3 moles of this, 3 plus 3 times 6 will give us what, 18 OH minus, giving us 3 BiO3 minus, plus this is 9 H2O plus 6 electrons. So for this side we have 2 MnO4 minus plus 4 H2O plus 6 electrons, giving us what, 2 MnO2 plus what, 8 OH minus. So now that we have them balanced, we can go ahead and write our overall what, reaction. So our overall, we just write everything that we have at both the top and then the bottom down, and then we get our overall reaction. So we write what, 3Bi 3 plus 2 MnO4 minus, then plus the electrons will cancel out. Now we have 4 moles of water over here, and then we have 9 moles of water, so it means water is greater at the right side, so we forget that. Now we have on the left side we have 18 moles of what, OH minus over here, then we have 18 of what, 8 of what, OH over here. So we subtract this from this, we will be left with what, 10 at this side. So we have 10 OH minus, giving us what, we write this 3BiO3 minus plus 2 MnO2, then plus, so we have 4 moles of water, 9 over here, so it will be what, 5 moles of water at this side. So we have this, and yeah, so this is the balanced overall reaction for this particular example. So this is how we balance redox reaction in basic medium. So we take it step by step. We add OH to the side deficient of oxygen, we add water to the other side deficient of hydrogen, and then we look for factors that will make the what, the OH and then the H balance, and then we go ahead to balance what, the charges, and then we do that for the reduction half. Then we add the 2 of them, and then we get our overall. Now when adding the 2, you need to consider the coefficient of the OH and then the water at both sides of the equation. So whichever part has the greater one, you subtract the least one from there and write the resultant at the other side of the equal to sign. So let's have a look at one final example for this tutorial. So the last one we want to look at is this one over here. So I'll go straight ahead without calculating. So the oxidation half over here is what, SO3 2 minus, leading to what, SO4 2 minus over here. Now we need to balance, alright, so we need to balance the oxidation half, and then we go ahead to balance what, the reduction half. So we have this, we have an OH over here, so this is telling us this is in what, the basic medium. Because of the OH over here, we are not told it is in acidic or basic medium, but because we know OH can only occur in basic medium, we are balancing this in basic medium. So now in basic medium we have S, so it's cool. We have oxygen here is 3, oxygen here is 4, so this side is deficient of oxygen, so we add what, OH minus, and then we add what, water to this side. Now because we've added that, we can see that when we add 2 moles of what, OH minus over here, and then just water over here, everything will be balanced. So we have 2 oxygen over here, this is 3, this is 2, so it's 5 oxygen, this is 4, this is 1, so it's also 5. So we have, this is 2 hydrogen, this is 2 hydrogen. So in terms of atoms, they are all balanced, so we are left with just the charge to balance. So we have what, the charge over here is what, -4. You have -2 here, these 2 multiply the negative here is -4. This side is only -2, so we add what, 2 electrons over here to make it what, -4 at this side as well. Now let's write the reduction half equation. Now because this is the oxidation half, it means automatically this one will be undergoing the reduction. So we have this giving us what? CrO2 minus. Alright, so the same way we have 4 oxygen over here. The chromium, they are all balanced, they are 1 1. We have oxygen over here is 4, oxygen over here is 2, so we need to balance the oxygen at this side. So we add what? OH minus to this side, and then we add water to this side. Now if we look at the factors that will balance both, we can see that if we add 2 moles of water over here and then 4 moles of what? OH minus over here, everything will be balanced. So let's look at that. We have 4 oxygen over here and then 2 over here, so making 6. So we have 2 here, we have 4 here, making what? 6. So oxygen is balanced. We have 2 moles of H2 over here, so which is 4. We have 4 oxygen over here, so it is also balanced. So we are left with the charge to balance. So we have what? Minus 2 over here, and then we have what? Minus 1, and then this is minus 4, so this is minus 5 over here. So we need to add what? 3 moles of electron to this side to have everything balanced. Now we can see that the number of electrons are not the same on both sides of the equal to sign of the half reaction, sorry. So we need to make sure they are the same. So we multiply the oxidation half by what? 3, and then we multiply the reduction half by 2. It is not always the case that you multiply our oxidation half by 10 then reduction half by 2. The examples that I'm using for this tutorial require that we use 3 and 2 for them, but it's not always the case. Sometimes you use 4, sometimes you use other factors just to get the number of electrons equal, the least as much as possible. So let's go ahead. So we have 3 SO3 2 minus plus what? This is 6 OH minus, giving us what? 3 SO4 2 minus plus 3 moles of water plus 6 electrons. So over here we have 2 CrO4 2 minus plus 4 moles of water plus 6 electrons, giving us what? 2 CrO2 minus plus what? 8 OH minus. So we now go ahead and write our overall reaction. So our overall reaction, we just add up everything we have over here. So we have 3 SO3 2 minus plus what? 2 CrO4 2 minus. We have water here is 4, water here is 3, so it means here has a larger amount of water, so we'll be left with what? Just a mole of water at this side. The electrons will cancel out, so we can go ahead and write what? 3 SO4 2 minus plus 2 CrO2 minus over here. Then we have 8 OH minus over here, we have 6 over here. So if we do the subtraction, we are going to get what? 2 OH minus at this side of the reaction. So this is how we balance redox reaction in both acidic and basic medium. I hope this tutorial was useful, and then if the tutorial was really helpful to you, kindly just subscribe to our channel and then press that notification button to get notified whenever we create new tutorials on biology, chemistry, mathematics and physics. So thank you so much for watching, and I'll see you in the next video. Bye bye.